Hello friends, welcome to Learner's Planet. Friends, in this session we are going to take some problems based on permutation and combination. In the previous session, I explained the difference between the two terms, what's permutation, what's combination, where we have to make arrangement, where we just have to do selection. So I am sure now you'll be clear about the difference between the two terms, that is permutation and combination. And I have already told you I generally do not use the term permutation. I proceed the problem with the problems with only combination, and a single formula I use, that is NCR, that is n factorial by r factorial into n minus r factorial. That is a single formula that I'll be using to solve the problems based on permutation as well as combination, right? Further, I would just make a quick recap. Combination is to select, strictly to select, and permutation is selection then arrangement, right? Now, how would we know whether we have to arrange the things or not? That is just by common sense or just common mathematics sense, right? There is no specific criteria there or cases which we can discriminate that in this particular cases we have to arrange, and the other cases we don't. In other cases we don't have to arrange, right? So we just have to apply the common sense, right? Let's proceed with the problems. Now, let's take this problem. Further, I would suggest you not to go on terminologies, just apply common sense. Now, three men have four coats, five twist coats, and six caps. In how many ways can they wear them? Now, since there are three persons and each of these three things, they would be required one each, right? So we need to select four coats, three coats out of four. So it's 4C3, right? Simultaneously, each will require one twist coat. So we require 5C3, then 6C3. That means three caps will be selected out of these six caps, right? Now, till here we have made the selection of three coats, three twist coats, and three caps. Now, suppose there are three persons. We are talking about these three persons. So these three are A, B, C. Now, till here we have made the selection only. Now, there are three coats, three twist coats, and three caps. But anybody can wear any coat, twist coat, and cap, right? So we have to arrange the coats, twist coats, and caps, right? So we selected three coats, and the three coats can be arranged in 3 factorial ways. That means A, B, C, between among these three persons, these three coats can be arranged in 3 factorial ways. Similarly, three twist coats can be arranged in 3 factorial ways, and three caps can be arranged in 3 factorial ways. So in all, this will be the complete solution to this problem, right? Because anybody can wear any coat. Maybe the three coats are white, blue, and black. So white, blue, black, or blue, white, black, or black, blue, white, whatever, right? So that's why 3 factorial arrangements will be there, right? So what 4C3 is? It's 4 factorial by 3 factorial into 1 factorial into 3 factorial into 5C3 is 5 factorial by 3 factorial into 2 factorial into 3 factorial, that is 6 factorial into 3 factorial by 3 factorial into 3 factorial, right? So just simplify that. So we'll be getting the answer. It's 24 into this is 120 by 2, so it's 60 into the 6 factorial by 6 by 3 factorial is actually 6, and 6 factorial is 720. So 720 by 6 is 120, right? So it's the answer will be 2 zeros. 12 6 are 48, or we can say like it's 12 and 12 cube, right? So it's 1728. So the answer will be 172800 ways, right? Further, Let's take this problem. It is required to sit 5 men and 4 women in a row so that the women occupy the even places. How many such arrangements are possible? That means in this case we have to make this 9 people sit. So I just take for the 9 places 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now I have 4 women and they have to sit at the even places. That means this and this, right? So these 4 positions are reserved for women, right? Now 4 positions are there and 4 women are there. So for 4 positions 4 women can sit in 4 factorial ways. That means how do I calculate that? For first woman, there are 4 choices. For the second woman, there are 3 choices. For the third woman, 2 choices. And for the last woman, there is a single choice. So 4 women can sit or can take 4 places in 4 factorial ways, right? Now, we have 5 men and we are left with the 5 positions. So 5 positions, 5 men, they can be arranged in 5 factorial ways, right? See friends, do not take 9 factorial because this answer and that answer is quite different, right? 9 factorial, that means all the cases are included where women can take any position, maybe odd or maybe even. In this case, women are set only on like even positions, right? Now what 4 factorial is? It's 4 factorial is 20 and this is 120, right? So it's 12 into 2, that means 144 into 2, 288, 0. So 2880 ways are there, right? We didn't use any formula over here, neither permutation nor combination. Simple mathematics sense, common sense we have applied. Now let's take this problem. Find the number of different 4-letter words with or without meaning that can be formed from the letters of the word number. Now friends, here we are having 6 alphabets, 1, 2, 3, 4, 5, 6, and we have to make 4-letter words only, right? And maybe they are meaningful or not meaningful, it doesn't matter, right? So first of all, what we have to do, we have to make a selection, right? Only selection we are making of in the first case. So to make 4-letter word, we need 4 alphabets, right? So out of six alphabets, we are selecting 4. So we have done the selection of 4 alphabets out of 6, right? Now to make different words, this 4 selected alphabets can be arranged in various manners, right? So 4 alphabets can be arranged in 4 factorial ways, right? It's selection, then after selection we are making the arrangement, right? So selection, then arrangement. So now we can solve this 6c4 into 4 factorial. 6c4 is what? It's friends, actually ncr is equal to nc n minus r, right? Why it is happening? Since n factorial by r factorial into n minus r factorial, and this is also the same thing, n factorial by difference of these two, that will be r factorial, then this a term alone, so it will be n minus r factorial, right? So this and this, both the formula are same, both the expression are same. So 6c4 is nothing but 6c2 into this is 4 factorial. Now there is one more short way to solve 6c2. Just reduce this number to this number till to this number, right? So 6 into 5, up to 2 step we have to reduce it, right? If there is 2 over here, if there is 3 over here, up to 3 steps we have to reduce, right? So up to 2 steps we are reducing it, then divided by factorial of this number. So it's 2 and 2 factorial, both the things are same. Now this is 24, right? So 6 5s are 30 into 12, 360 ways will be there to make 4-letter words from the letters of the word number, right? So I hope you are clear. First of all, we have done the selection, then after selecting 4 alphabets, 4 letters, we arranged them in 4 factorial ways, right? Because different arrangement will produce different words, right? Actually it is a permutation, but I am not using the term permutation. What I am doing, I am selecting the objects and then arranging them, right? Now in this case, how many words with or without meaning can be formed using the letters of the word triangle? Now friends, there are 8 letters in this word, right? Now we have to use all of them. That means we have 8 choices, right? Now 8 letters to be arranged at 8 places. That means 8 factorial ways are there, right? Because we don't have to choose the letters, because we have to use all the letters, right? So what we can say, it's the or like if we go by this way, at first place 8 choices are there, second place 7 choices, 6, then 5, 4, 3, 2, 1. So it's nothing but 8 factorial, right? Or we can say 8 places are there and 8 objects are there, so they can be arranged in 8 factorial ways. This you don't have to do this, right? Now friends, let's see this problem. In how many ways can the letters of the word pencil be arranged so that we have 2 conditions, right? We take 3 questions from this question. The first is without any restriction, right? I have to make different words of using the letters of word pencil, that is 1, 2, 3, 4, 5, 6, right? The first is there is no restriction. Then how many words I'll be able to form? That is 6 factorial, right? 6 letters are there, that means 6 places are there, and 6 places are to be filled up by 6 letters. That means 720 or 6 factorial ways will be there. So that is no restriction, no condition at all. Now we take this condition, that is n is always next to e. That means, see, we have p, c, I, L and n and E, right? N is always next to E. That means what we want is the situation, right? E and N. Now I take this as a single word because we have to make them together. We have to set them together. So I just take it as a single word. Now the single word can be arranged wherever, anywhere, right? So now I have 1, 2, 3, 4, 5 objects and 5 places, right? Because I'm considering this as a single object, right? But this single object can be placed here, 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 and here or here, right? So this single word can move anywhere. So I have 5 places and 5 letters to arrange. So there will be 5 factorial ways, right? Now the other case is N and E are always together. Now in this case also N and E are together, but we were having a condition that N is always next to E. That means E N should be the order. Now if N and E should only be together, then E N and N E, both of them are, both the conditions are, or both the events are acceptable, right? So apart from this 5 factorial, this NE will also be acceptable. So the we will be getting 2 arrangements, right? So 5 factorial into 2, that will be the total number of arrangement. I further repeat is this P, then this is, I just typed them. So 1, 2, 3, 4, 5, 5 factorial ways are there, and E and N can be arranged in 2 ways, E N and N E, right? So 5 factorial into 2 ways are there to make this arrangement, right? For the previous one, the answer was 5 factorial only, but for this one, 5 factorial into 2, right? And this condition was there, that like N is always next to E. So we were restricted for this. Here we have the 2 choices, E N and E, right? So we got the more number of ways, or we can say double number of ways, right? So I hope you are clear. What is the difference between these two? Now we have already done this problem of triangle. Now there is some restriction on the arrangement. Now how do we do that? How many words can be formed from the letters of the word triangle? That we have already discussed. There are 8 letters, so 8 factorial ways will be there. Now how many of these will begin with T and end with E, right? Now we have 8 places, 1, 2, 3, 4, 5, 6, 7, 8. At this place T is fixed and at this place E is fixed. Now we are left with 6 places and 6 letters. So 6 places and 6 letters, they can be arranged in 6 factorial, that is 720 ways. When we were having no restriction in the previous case, the ways were 8 factorial. Now there is a restriction that the first letter should be T and the last letter should be E, right? So we got the ways reduced because now we are left with the 6 positions and we have to arrange the 6 letters. So this is the second case. I would like to share the third case also, when it is told that T and E should be at the extreme places. That means this is the first position, this is the last position, so we call them extreme positions, right? Now if the question is that T and E should be at extreme position, that means at the first place T and the last place E, or at the first place E, last place T. So that is also acceptable, right? So for that also 6 factorial ways will be there, but at the first place E and the last place T is there. So T and E can be arranged in 2 ways. T and E or E and T, right? So in all, for the third case, 720 into 2, that is 1440 ways will be there. So you got the 3 questions in this particular question. First is no restriction, that is 8 factorial ways will be there, and the second case, the first position should be taken by T and the last position should be taken by E, and the third case which I created the problem over here, that is the extreme position should be taken by E and T. That means T and E, this combination is allowed, as well as E and T, this combination is also allowed, right? So for the third case, we have the answer as 6 factorial into 2, and I am sure now you are clear the difference among these 3 questions, right? Now friends, let's take the set of problems. Here there are 5 conditions. So it will be good to solve this problem because various aspects we have to see. So I think the concept will be cleared after we solve this problem, right? Now, how many words can be formed by the letters of the word vowels when, first of all, we take there is no restriction. So how many letters are there? 1, 2, 3, 4, 5, 6, right? We have to choose all the letters because it's not mentioned that how many letters we have to use. So I assume that we have to use all the letters, right? So 6 letters, that means 6 places to be filled up by 6 letters, and there is no restriction. That means there is 6 factorial ways, right? So the first problem is quite simple. Now let's come to the second problem. Each word begins with E, right? So we have 6 places. I just do it over here. 1, 2, 3, 4, 5, 6, right? For the first place, we have restriction that we have single choice that letter E should come. So we have just one choice for the first place because the word should begin with E. So first place is fixed for E, right? Now we have 5 places and 5 letters left out. So the 5 letters at 5 places can be arranged in 5 factorial ways. That means 120, right? Now the next is, so we are clear with this, each word begins with O and ends with L, right? Now further we have 6 places, 1, 2, 3, 4, 5, 6. For the first place we have one choice that O should come. For the last place we still have one choice that L should come. Now for this center place and the places over here, 4 places we are left and we are left with 4 letters. So 4 places, 4 letters, 4 factorial ways will be there to arrange them, right? So that's 24, right? So this is also clear. Now the next is all vowels come together, right? Now first of all, how many vowels are there? Let's see. V, O, W, E, L and S. So 2 vowels are there. So what I do, I just take them as one letter only. So what I do is O, E, I treat it as one, and V, W, L, S. So 1, 2, 3, 4, 5. Now I am left with 5 letters. Now 5 letters can be arranged in 5 factorial ways, right? Now here it is told that all vowels should come together. That means I have tied up, or I have combined O and E and getting 5 factorial ways, but the other order is OE and EO. Both the orders are acceptable, right? So O and E can be arranged in 2 factorial ways. So what we did at the first case, we arranged these 5 letters. I'm taking this as 1. So 1, 2, 3, 4, 5. 5 factorial ways, and we arranged these 5 letters. Then in 2 factorial ways, O and E, both of them can be arranged, right? So it's 120 into 2, 240 ways will be there, right? If it is mentioned that E should follow O, then this only 5 factorial ways will be there. But if it is told that O and E should be together, then there will be 2 factorial ways multiplied by 5 factorial, because O and E with these is also valid and E and O order is also valid, right? So O and E can be arranged in 2 factorial ways, right? Now all the consonants come together, right? Now we don't have to like this take O and E together. Now we have to take V, W, L and S as one word, then O and then E. Now we have 3 letters. I'm treating this as 1 only. So 1, 2, 3. 3 letters can be arranged in 3 factorials. Now we have to keep the consonant together, but the consonant can change the position inside, right? Like they can change the among themselves, they can change the position, right? That is VWLS or VLWS or SLWV or SWVL, whatever, right? So these 4, they, while they are together, they can also rearrange themselves, right? So these 4 can be arranged in 4 factorial ways among themselves, right? So first we did, we arranged these 3 letters, then we arrange these 4 consonants among themselves in 4 factorial ways. So 3 factorial into 4 factorial, that is 6 into 24. So that is 144 ways are there. Well, all the consonants will come together, right? So we discussed the 5 conditions, and I hope you are clear now. Now let's take this. How many words can be formed out of the letters of the word article so that vowels occupy even places? Now we have 1, 2, 3, 4, 5, 6, 7. 7 letters are there. So 1, 2, 3, 4, 5, 6, 7. Now we have 1, 2, 3 even places, right? And we have how many articles? That is A, I and E, right? A, I and E. And the remaining are R, T, C and L, right? So these 4 are consonant and these 3 are vowels, right? Now we have to arrange the vowels on 2nd, 4 and 6 position, right? So we have 3 positions only, and we have to arrange the 3 letters only. So 3 letters, 3 positions can be arranged in 3 factorial ways, right? Now we have to arrange the consonants on the remaining 4 positions. So 4 positions, 4 letters, they can be arranged in 4 factorial ways, right? So it's 6 into 24, so it's 144 ways are there, right? Now this question, how many words with or without dictionary meaning can be made from the letters in the word, from the word Monday? We have 6 letters over here, assuming that no letters is repeated. See, we have to make 6 letters word only. Now further we have see, now in the first case we have to use 4 letters, right? And we don't want any repetition. Now it's a good problem. Let's do it. Now in the first case we have to use 4 letters, right? Now how many letters we have? 1, 2, 3, 4, 5, 6. So from these 6, first of all we need to select the 4 letters. So 6C4, that means from 6 we are selecting 4. Now this is what we have made the selection. Now these 4 selected letters can be arranged in 4 factorial ways. So in all, this will be the answer to this problem, right? So 6C4 is what? 6C2 into 24. Now what 6C2 is? 6 into 5 by 2 into 24. So it's this. 5 6 are 30 into 12, 360, right? So when we are choosing 4 letters, we are making 6C4 4 letters are selected from 6, so 64, and the selected 4 letters are arranged in 4 factorial ways, right? Now all the letters are used at a time. That means 6 places are there and 6 letters are there. So it's 6 factorial, as simple as that. Now all the letters are used, but the first word is a vowel. Now we have 1, 2, 3, 4, 5, 6, right? Now how many vowels are there? It's O and A, right? 2 vowels are there, O and A. Remaining are M, N, D and Y. Now according to condition, the first letter should be a vowel. Now we have first place and we have two choices that either O or A can come, right? So for the first place, we have two choices, right? Now first place is filled up. Now we are left with 5 letters and 5 places, right? So 5 letters and 5 places, the numbers of arrangements will be 5 factorial, right? So it is 2 into 5 factorial. We can say 2 into 120, that is 240 ways will be there, right? So all the letters are used, but the first is vowel. So for the first place we have two choices, right? And we have filled up one. Now we are left with the 5 places and 5 letters, so these can be arranged in 5 factorial ways, right? So 2 into 120, 240 ways will be there, right? I'm sure you are clear now. Now friends, let's take this problem. Here you can see arrangement of words is there, but we have repetitions also, right? So this A, 1, 2, 3 times this A is coming, right? So we have to make the different words using all the letters of word Haryana, right? So it's H, A, R, Y, A, N, A, right? Now friends, if the letters are repeated, then obviously the number of different words will be less, right? How do I ensure that, right? Suppose I take maybe a small example. Suppose I have the letters A, and B, right? These 3 letters are there with me and I have to rearrange them in various ways, right? So how do I do that? Say this A, and B. The next arrangement will be A, B, A, right? And the third arrangement will be B, A, right? Now I don't have more arrangements because these two A's are identical, right? So what is the concept over here? Suppose I have A, B, C. Then how many ways will be there? A, B, C, A, C, B, B, A, C, BCA, CAB and CPA, right? So in this case I have 6 arrangement, but in this case I have just 3 arrangement. Why? Because 2 letters are same, right? So if we have n places and n objects to arrange, so there will be n factorial ways, but we have to divide by the repetition, right? In this case 2 letters are repeated, so I would divide by 2 factorial, right? So for this case n is 3, so 3 factorial by 2 factorial, that is 3 into 2 by 2. So 3 ways I'll be getting to arrange these 3 letters when these 2 letters are repeated, right? Since there is no repetition, we'll be getting 3 factorial ways over here, right? So if we have the repetition of the letters, we have to divide the total number of arrangements by the repetition, right? So suppose if we talk about Haryana, A, and A, the 3 letters are repeated. So we have unique letters. How many unique letters we have? 1, 2, 3, 4 and this A is 5, right? So what we do? First of all, we 3 and 3, 6, 7 factorial ways will be there. Since we have to fill up the 7 places with these 7 letters. But since A is repeated, we need to divide it by 3 factorial. Now A is being repeated for 3 times, so I'll divide it by this expression by 3 factorial, right? So 7 factorial by 3 factorial, these are the number of ways when the different letters or all the letters of word Haryana can be arranged, right? So for the first case, our answer is 7 factorial by 3 factorial. Now let's take the second case. Now, in this case, how many of these begin with H and end with N, right? Now I have 7 places. 1, 2, 3, 4, 5, 6, 7. For the first place, H is fixed. for the last place n is fixed, right? So we are, here we have just one choice, here we have just one choice. Now we have 5 places and we have to fill up 5 letters, right? And the remaining letters are, I just cancel h and cancel n, right? So remaining letters are 1 2 3 4 5, right? So 5 places, 5 letters, they can be arranged in 5 factorial ways, obviously, and we will divide by the repetition, that is a is being repeated for 3 times. So 3 factorial we will divide, right? So 5 factorial is what, 120, and this is 6, so it's 20 ways, right? So 20 ways will be there when the words begin with h and ends with words end with n, right? So this is also clear. This is 20 ways. Now let's take the third one. Now in this case, in how many of these h and n are together, right? I just write h and n together, and the remaining are a, r, y, a, and a, right? I just treat them as one single letter. Now this is 1 2 3 4 5 6, 6 letters to be arranged in 6 factorial ways. The second thing is we have to divide by the repetition, that is 3 factorial. Then we want h and n together, right? So h and n can be rearranged among themselves in 2 factorial ways. Do not forget this 2 factorial, otherwise your answer will be wrong, right? So 1 2 3 4 5 6, 6 factorial ways are there, and we divided by the repetition, that is 3 factorial. Then h and n can be mutually arranged in 2 factorial ways. So in all, this is the answer. So 720 by 6 into 2, right? So your answer will be 240, right? Friends, we have done a good number of problems in this session, and we'll be taking more problems in our coming sessions. Okay, so do revise this session so you'll feel comfortable in the next session. See you. Bye-bye.